Nope. That's not the reason. It doesn't need one, but that's not the reason we use. That's right. You look on your blue card, and beside sodium on the blue card, how many numbers are listed beside sodium? One. Because there's only one number on the card, that's the reason it doesn't get a Roman numeral. Okay? So when we do nickel, all right, Ni is nickel. What's O? Oxygen, and we make it what ending? Oxide, because again, there's only two capitals. So when we look at that, how do we decide if it needs a Roman number? All right. How many Roman number or oxidation numbers does nickel have? It's got 3 out there, right? Now, put your blue cards down. The 3 only tells you need a Roman number. It doesn't tell you what the Roman number is. The Roman number comes from the formula. So looking here, what number came from oxygen? The 2 came from oxygen, which is what I asked. The 3 came from the what? Nickel. All right, so the 3 goes here with the nickel. So nickel 3 oxide. Now, PbS2 I gave you sort of is a prequel to what we're going to do on Monday. Okay? Now, when we go to do PbS2, Pb symbol is what? Lead. S is sulfide. Now, this is one that we're going to discover on Monday has been reduced. If you look up sulfur's oxidation number, it has a -2. There should be a 2 right there. Is there a 2 right there? No. So what happened? It reduced. In order to put in the oxidation number, you have to figure out what the formula used to be. Okay? So, to figure out what the formula used to be, you take this 2 and you multiply it through the subscripts. So 2 times 1 is 2, and 2 times 2 is 4. So it used to be Pb2S4. So what number came from the lead? 4. So that's the Roman numeral that lead would have. Okay? That's where we're going on Monday. Okay? You will not see that today in your lab. All right? All right, so in the bottom, calcium nitride. What's Ca? Oxidation number. Nitride is, what's its symbol? Okay, what's its oxidation number? -3. So 3 comes down, 2 comes down, you have Ca3N2. All right, aluminum iodide. Aluminum is Al. It has a 3. Iodide has a 1. Bring a 1 down. 3 down. You have Ali3. Everybody okay with that? Okay. The last 2 have the polyatomic ions in it. I gave you this one today because it's an exception. There are 2 polyatomic ions that end in IDE that are exceptions. Cyanide and hydroxide. Okay? They're both listed on your sheet, so it's not like you have to memorize them. You just got to find them. So lead is Pb. It has an oxidation number of 4, and hydroxide is OH with a 1. Parentheses, bring your 4 down, bring your 1 down, and so your formula is Pb, OH with a 4. Now, we have to write the parentheses, and a lot of people leave the parentheses off. The reason you have to write the parentheses is what number is outside the parentheses? A 4. I told you yesterday you can leave the parentheses off if the number is a what? A 1. Okay? Does that make sense? All right. And the last one, calcium is Ca. Its oxidation number is a what? A 2. Chlorite. What's chlorite's formula? All right, ClO2 and a -1 charge. So I'm putting parentheses around the polyatomic ion. All right, and then I'm crisscrossing the what? So the 2 is coming way over here, and the 1 is going over there. So I get Ca, ClO2 with a 2. Questions? Yay or nay? Can we talk homework?
Yes.
Okay. Who stole my stool? Some fool in 3rd period. Oh, the same fool. I had to put his laptop up. All right, let's do the formulas first, and then we'll do the names. Or, no, the names first is on front. So let's do the names first. All right, question number 9. Should be copper 2 chloride. Copper 2 chloride. That one has to have a Roman numeral. Number 10, magnesium bromide. Number 11, calcium oxide. Number 12, iron 3 oxide. Number 13, manganese 7 oxide. 14, silver fluoride. Number 15, potassium iodide. 16, aluminum nitride. 17, tin 2 chloride. 18, barium sulfide. And 19, lead 2 iodide. Any issues? Anybody need me to do any of those? Potassium iodide. Really? I'm not doing all of them. Ask somebody over there. On the back side, Ag, parentheses, NO3, close the parentheses. Now, the parentheses are completely optional. You do not have to have them because what number is outside? 1. So you could just write Ag, NO3 there. Okay? That's what I'm talking about where the parentheses are not needed because the number outside is a 1. Same thing in number 2. Na2, parentheses, SO4, close the parentheses. You can leave the parentheses off because the number outside is a 1, so you can just write Na2, SO4. You get the idea? Okay. Number 3, they're not optional. Fe, parentheses, ClO2, parentheses, 3. 4, Pb, parentheses, ClO4, close the parentheses, 4. 5, Zn3, parentheses, PO4, close the parentheses, 2. Number 6, you just look up on the sheet with the acids and write down H2SO3. 7 is NaClO3. ClO3 can be in parentheses. Number 8, Al2, parentheses, SO4, close the parentheses, 3. Number 9, Mg, parentheses, NO2, close the parentheses, 2. Questions? Somebody show Cameron the answers to. Number 4 is Pb, parentheses, ClO2, close the parentheses, 4. Anybody? Questions on how to do any of those? No? Yeah.
So when it says 8 and I, so the ATE and ITE doesn't matter?
Well, the biggest thing is it does, but because you're using the sheet, you just have to look up the right ion. So when I say ITE, so like in this one, you just need to make sure that you look up the one that says ITE. And if it says ATE, you need to make sure you look up the one that says ATE. But the difference is ATE will have one more oxygen than the one that has ITE. So like if you look here at ITE, it says ClO2, and ATE says ClO3.
Oh,
That's the difference. It's an oxygen.
that's all.
And if you have one that says like perchlorate, if we look down here and we find one that says perchlorate, it's going to have one more than the chlorate. So it's ClO4. If I was teaching like a second level of chemistry, you would have to know how to do that. But because we're not, it's not part of our curriculum, so I won't teach you how to do hypo, chlorite, chlorate, and perchlorate, and how to figure out how many oxygens there are. Yeah, you don't have to know that first year. All right, any questions before we talk about the last piece and then we'll do the lab? No? All right. So the last piece that we didn't get to yesterday is, oh board, is writing names with polyatomic ions. Okay? We need to be able to write names with polyatomic ions. Now, again, we don't really need to write down any new steps because we wrote steps down yesterday. All right, so let's say that we have a formula like FeCO3 with a 2 and a 3 there. Now, these are the easiest to do because they have parentheses in them. All right, and the parentheses ones are always the easiest because they scream to you, I have a polyatomic ion. Okay? And we're going to do one with and one without to point out the differences. Now, the first thing you should notice compared to the ones you wrote the names for last night is, how many capital letters do you have here?
3.
3. Okay? So the first thing you should notice is it's not binary. So there's going to be no IDE ending. Okay? There's going to be no IDE ending on this. You're going to use the oxidation sheet for the name. We're not going to have to figure out the ending. We're not going to have to match anything up. Just going to use the name on the sheet. So, just like last night's homework, tell me the name of Fe. So you write iron. Now, after you write iron, everything after the iron you write together for one name. So you look up everything after that Fe together on your blue card and find its name. So what is the name of that thing? Yep. All right, I know an A's got it. So look up after you found or finished your notes and see if you can find it. What'd you find? Did everybody find carbonate? You got it over there, Cameron? Okay, so we're going to write carbonate. We do not write the word ion. It's an ion as long as it's on that oxidation sheet. But once we take it off the oxidation sheet, it's not an ion anymore. Okay, so iron carbonate. Now, from there, whoops, it's not carbonate. I need an O there. Carbonate. Now, from there, we need to check, just like last night, the first element. Does it need a Roman numeral? How do we check to see if it needs a Roman number? All right, I heard Eiley say our sheet. So, what do we do on the sheet? Check how many oxidation numbers it has. So, if I check my oxidation numbers, how many oxidation numbers does iron have? It's got 2. So, yes, I need Roman numerals. So, what do I do to find my Roman number? All right, I look at the formula and I say, this 3 came from iron, so I'm going to put plus 3. Any questions about that? Everybody with me? Yeah? Okay. Everybody's there. Everybody caught up with how to write it? Okay. So, one without parentheses. Now, when I give this on a quiz or a test, I get some really messed up answers. I mean messed up. You are not going to write all those elements separately in name form. You are doing exactly what we just did. You're going to name that first element. So, what is the name of the first element? You're going to write potassium. that, again, you're looking up everything else for that name. Even though it's not in parentheses, you're looking up everything else together for its name. So what is the name of S2O3 together? Thiosulfate. So you're going to write thiosulfate. And then you're going to check to see if you need a Roman numeral. And then Andy said, no. He said, we don't need a Roman numeral. So, how do we know that? That's right. Potassium only has one number. And since potassium only has one number, we're done. Questions? Anybody have a question on how to write the names? Think you feel okay with how to do? Thank you. Think you can cut and glue and paste? Yes? All right. I need 2 people to hand out my papers, and then we'll talk about some directions. Actually, give me 3 people. I can go ahead and hand out the homework. That way my people who have to go to the practice have their homework, and I don't have to feel bad if I check it and y'all don't have what you need. You got the homework. You got the outlines. You got the directions. Let me grab more construction paper because I don't know if I have enough paper. Let me grab a couple extra sheets. Let's see if I got enough now. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10, 11, 12. Thank you, my dear. Yes. No. Yeah, if you want to, but I wasn't planning to. Good? Oh, don't call any. I don't have any protections. All right. Does everybody have 3 sheets? All right. First of all, one that says naming worksheet number 2 is your homework. You know 1 through 20. Okay, 21 through 25 is covalent naming. We haven't done covalent naming, so don't worry about those. 1 through 20 is your homework. Now, we're supposed to have a quiz Monday. We may or may not have it. It will depend entirely on the schedule. I've seen the schedule. I suspect I will move it to Tuesday because first period, even though they say we're going to have time before the assembly and after the assembly, I suspect we'll get jacked up. So it may wind up being Tuesday. But 1 through 20 is your homework. Now, put that away so that we can work on the lab. Now, those of you who have to go to the assembly practice, you're going to need to get this done. You're not going to have enough time, so you may have to come see me during your lunch on Monday. Keep that in mind. Huh? You can come and I'll have you do it in Dr. Phillips' room like I did today for the people who have lunch during my other class so that you don't have to intermingle with them and it can be quiet and peaceful for you. He didn't mind that at all today. Okay? Now, you're going to do this. I'm going to use magnesium and chlorine as an example. Now, why do we crisscross? Crisscrossing is a shortcut for the actual process. When we combine elements in a compound, I think he's just playing with the paint on the wall. I don't think he's some kind of weird stalker. All right, that or he's maybe cleaning cobwebs off, but sometimes the paint peels and they work on the paint. I think he's legit, though. All right, some weird dude on the wall out there at the window. All right, so we have magnesium has a +2 and chlorine has a -1. When you combine the two, do the oxidation numbers total 0? Big math class. So we have to add some magnesiums and some chlorines until the oxidation numbers total 0. Well, what would I need to add to get them to total 0? Say what? You're kidding me.
Oh no, we can hit sign a card. He's got the papers, we can sign now. What do they bring? I guess they don't want to talk to me today.
All right, I'm sorry. Thanks for signing up for the suicide awareness quiz. You can tell Ms. Curtis can't be up to this. But
It's all good. I'm not doing
ice
anything.
cream. If you have any your certificates, the little cards. Okay.
Who didn't sign and wants to sign? Go see Mr. Kinzer. Like, super quick.
Okay.
Who did sign? Go see Mr. Kinzer in another line, like, super quick. Because y'all are eating your lab time up and you got to be done by 3:30 because it's Friday. And I don't stay late on Fridays. Only Mr. Kinzer does because he's crazy.
That's right back to us.
Me either. I get back in today because I'm going to run over people in my way today at 3:35.
Oh, yeah, it's right.
You don't want one passion? Okay, now we got to work on this. Those even look like healthy ice creams. You said no. See, if they were chocolate, I might go on this, but they're not chocolate.
I know,
I thought they
were going to be.
So excited. All right. So if we look at what we have right there, you have a magnesium and a chlorine. We said they don't total 0, right? So if they don't total 0, and I added another magnesium, for example, is it going to equal 0? No. Now, what if I added another chlorine? Would that total 0?
Yes.
Yes. Now, that would mean that when I wrote the formula, how many magnesiums do I actually have? I have 1 magnesium. How many chlorines do I have? I have 2. Now, that and figuring out how many atoms you have to total 0 is a pain in the rumpus. It is much easier to use the oxidation numbers and simply crisscross them. But crisscrossing is a shortcut for this. Okay? So, on the lab today, we're going to do 3 things. We're number 1, going to glue down the ions to figure out how to get the oxidation numbers to total 0. That's the first thing you're going to do. And I'll leave this up so you've got the directions in front of you. Number 2, you're going to write the formula. Now, you can do it either way. You can crisscross, so you can do the whole 2 Cl and bring your 2 and your 1 down like we've been doing. Or you can count and you can say, I glued down 1 Mg and I glued down 2 chlorines. That way. I don't care which way you do it as long as you get the formula. And then number 3, you're going to write the name. Now, remember, if it's binary, you put what end on it? IDE. If it's a polyatomic ion name, you get it from the polyatomic ion column. Now, let me point this out because, excuse me, lots of people make this mistake. Look on your direction sheet. You see in the middle of the paper where it says, under step 2, where it's got those 10 compounds, it says aluminum and bromine. Did I write and in the middle of any names in the last 2 days? No. Don't write and in the middle of any of your names. It's not aluminum and bromine. Write the name the way it's supposed to be written today. When you get to where you're writing the ions, did I write ion in the name of anything in the last 2 days? Remember, when you combine it, is it an ion anymore? Okay, so when you, that's right, you're going to put the ending on it, but you're going to get rid of that ion part when you combine it. So don't put ion in the name. Okay, on the back table, I've put pink construction paper for you to glue stuff down on. There's markers. There's more markers over here if you want more markers. There's glue and there's scissors. For those of you who get all happy with the glue, I do not want glue all over the counters. So get white paper or pieces of your notebook paper. If you're one of those people who runs the glue off the little squares and gets glue all over the counter, that's hard to get off my brand new counters, so don't get glue all over the counter. You do not need to glue it down for the next 500 years. It just needs to stick until I break it. Also, the ions, you're going to run out. There's not enough on there, so when you run out, draw what you need. And you may have some extras at the end. The extras just throw in the trash can. I do not need the instruction sheet back. I only need to pick a piece of construction paper. Any questions? Got it done by 3:30, other than my people who are going to the assembly. Don't waste your time and talk like those few did, which is why they had to come during lunch.
We come to you for help.
If you get stuck, yes, you may have to that. Yes. Yes. It looked nasty to me. I know. I thought they were gonna have like stone crushing. They don't take the bag out.
Oh, thank you.
Oh, and as a tip, I probably wouldn't cut all the ions out first, because then you spend all your time hunting for the ions in a big pile. But you can do that if you want. And no more than 4 people at a counter.